Okay, in this session we're basically going to talk about very quickly some installation principles and some of the problems that we've seen on installations not only in California but everywhere else in the country. I'm not going to cover basic layout and installation because anybody who installs guardrail for a living or supervises contractors know you pretty much know how to do that. The biggest problem often comes with maintaining something that's been hit in to the same extent that it was originally installed. Anyway, we're going to look at some common installation errors, both for guardrail, for the terminals, and then a quick inspection checklist. The correct height is important. Remember, 27 inches is not effective for the new MASH testing. The MGS system at 31 inches is a great improvement, not only because of the height, but because of the post-release mechanisms and everything else. And again, that's what CalTrans is moving to. Okay, we saw these earlier. That's too low. A vehicle, especially a small vehicle, can get under it. This is a weak post system, not commonly used here in California, but you still got the underride problem. If you put the barrier up a slope somewhat, you've got the curb, you've got the vehicle going upward before it even hits the barrier, good chance it's going to go over and smash into whatever you're trying to shield in the first place. The lapping is relatively important. It should be lapped in the direction of traffic, so anybody hitting the rail and sliding along it doesn't have a panel edge that could possibly tear and snag the vehicle or cause the rail to rupture. And basically, it should be lapped in the direction of traffic. For traffic going this way, it should be lapped as shown here. For opposite direction traffic, it should be lapped in the opposite direction. Sometimes a question comes up when you have a terminal on the departure end, do you change the lap? And the answer is basically no. These have generally been tested or allowed. You have to install the terminals as recommended by the manufacturer. The one possible exception, or the couple possible exceptions, the SKT, the sequential kinking terminal, the fleet, and I guess the ET as well. Anything that flattens or kinks the rail, it doesn't matter to that head which side the lap is on. It'll kink it, it'll feed it through the chute, regardless of which way it's set up. Okay, in this one you can see, if you look very closely, that the end shoe is lapped the wrong way. If you look even closer, you can't tell because you weren't there, but these posts are the most rotten posts I've ever seen. You can almost kick them over. You can tell there's something wrong with them, with grass and little trees and twigs growing out of the tops. Great mushroom habitat. But anyway, just driving by at speed, you might not notice that. If there's some splice bolts missing, that could be a problem. You've got a weak link. The post spacing must be accurate. It's critical, particularly in transitions. If you have to omit a post with standard metal beam guardrail, there's a design where you can actually eliminate two posts, but to cover the span, you have to nest the rail, and then you have to have breakaway posts on the upstream and downstream side of that clear span. So if the span is deflected, you don't get pocketing when you start getting to the post. Those two end posts on either side are going to break away, so you're going to get a gradual stiffening, pretty much like a transition design. Now the MGS, you can omit 3 posts. You don't need to nest the rail, but you still need breakaway posts on both sides of it. So again, you can span a pretty big distance with the MGS without requiring nested rail or any other significant changes other than breakaway posts on either side of it. Additional blockouts, again, if you have to, and that might be a solution to Alice's concern. If you can use, if by using 2 blockouts, you can get the post further away from that water line so you don't hit it, that is an acceptable practice. And you can use either one additional blockout for any number of posts, or you can use 2 blockouts for up to 2 posts. If you're using MGS, you can use 2 12-inch blockouts or 3 8-inch blockouts. So that allows you to set the post further back, and if that's enough to clear the water line, that might be a good solution. And sorry I didn't think of that when the question first came up.
Well, excuse me, but the crash testing was done based on one block, am I correct?
The initial crash testing was done based on one block, and I'd have to be honest with you, I'm not sure if the additional blockouts were tested or not. I think they probably were, you know, particularly for the MGS, but I can't sit here and say with a straight face, I know that's a fact.
But that would be on a wood block, not a steel.
So you're not sure if that's.
Yeah, we don't use steel blocks anymore. And with the plastic blocks, I don't think any of the designs allow you to use more than one. But yeah, we'd be basically talking about a timber offset block. Okay, the barrier should be delineated, and again, CalTrans requires post-mounted delineators behind their guardrail installations. A very good idea. Improper application. This apparently is an area of roadway that gets a lot of sand and silt and mud across the road during rainy weather. They've got basically a dry arroyo coming through here, and they put some K-rail here to, I guess, keep people out of the hole. But remember, first do no harm. By having a blunt end of the concrete this close to the edge of the pavement, not very good, and you've still got a hole here or somebody could get into. If you added some additional K-rail sections with a flat flare rate and brought it way back here, you know, that would be good. But the way it is now, you've probably made the existing situation somewhat worse. We talked about this before. We've got, you saw this slide, you've got excessive pocketing here, probably because the end anchor failed. And here you've got absolutely no deflection distance. And you've got a utility pole almost right in the middle of the shoulder. All of these things are tested individually, and again, the occupant impact criteria is one of the key evaluation elements. You can't stop them too quickly. So when you put two of them together in a location where you could possibly hit both of them at the same time, you're asking for trouble. I guess putting the sign in here gives motorcyclists a way out, provided they've got brakes good enough to stop on grass before they disappear into the trees. Okay, this this is an X-Lite terminal. I think you can just barely see the yellow shear bolts down here. You've got the special bracket that gathers up the rail and allows it to telescope, but it's fairly close to this definitely non-breakaway support. And it's hard to tell from this angle, but the deflection distance may be inadequate as well. And then, of course, every once in a while you get something like this. Now, some people say, well, this is a breakaway pole. It may very well be, but it should have a stub height or a base height of no less than 4 inches. And the problem with this is if you hit the rail and the rail starts redirecting you, it's going to bring you right into the post. Not sure what was there first, the post or the guardrail. And if this is the only post or if there's a whole line of posts, but in any case, you can look at it and say, yeah, that doesn't look right. Now the terminals get a whole lot more complicated because there's so many different ones out there. They're not necessarily interchangeable. A non-crash-worthy terminal is okay on the trailing end, but it still has to be an anchor. You need tension in the rail if somebody hits it close to the departure end. And again, all the manufacturers have detailed installation instructions, and they have detailed checklists so the inspectors can go back afterwards and make sure all the parts are properly assembled. And this of course is an SKT. You can tell by the open panel here. It's also important to realize that for the SKT in the fleet, because it kinks the rail, it takes more energy to kink the rail than it does to flatten and bend it. So a special end piece is required that has relatively short slots cut in it. If you use just a regular piece of W-beam here, the initial impact with a small car would likely be too high. So it's critical to recognize that this terminal and the fleet require a special end piece. Okay, and this shows it. Again, this is not to be confused with a slotted rail terminal, which has long slots. And we've seen some mix and match where somebody's used a slotted rail end piece with an energy absorbing head. And remember that rail behind the energy absorbing head has to be straight. It has to be strong in column strength. So if you use a slotted rail behind something that requires the rail to be stiff, what's going to happen? Somebody hits it on the end and it's going to just start crumpling up. It's not going to extrude. It's not going to slow the vehicle very much. The other thing that's important is the bracket that holds the cable to the rail. For the ET, it's basically square holes and it's got kind of a fish hook-like arrangement. So it's pretty easy to put that in. You can't mess that up very much. But excuse me. With the sequential kinking terminal and with the fleet, it uses special shoulder bolts because you don't want that bracket strongly, firmly attached to the rail. And why is that? Because the bracket will not go through the extruder head. It will jam it up and it'll cause everything to come to a quick halt. So you need to be sure that when the extruder head is pushed back and hits the bracket, it releases the bracket from the W-beam. If you bolt that down as tight as possible, then it's not going to release and you're not going to get proper deceleration. And the way they keep it from being too tight is, again, they use special shoulder bolts that aren't threaded along their entire shank. They've got a short section that's unthreaded, so it's impossible to make it too tight. And you can always tell if the proper shoulder bolts were used because this is about the only terminal where you'll see the nuts on the outside of the rail if it's installed properly. If you look at an SKT and fleet and you don't see those nuts, somebody did something wrong. Okay? And again, that's something that we see from time to time. You know, they will go in the other way, but it's improper and the bracket won't release when it's hit.
Back to your slide where you were talking about non-crash worthy on the trailing ends. That all depends on the roadway, doesn't it?
Sure. Yeah, if you're using a non-crash worthy terminal on the departure end, it should be on a freeway or a one-way roadway, or it should be on a road where the terminal is outside the clear zone for opposite direction traffic. But as I said earlier today, clear zone is kind of a nebulous number. If there's any way that it can be hit from the opposite direction, the recommendation is to use a crash-worthy terminal, even if it's a couple feet outside that magic clear zone number. Okay, this is all pretty straightforward. I'm going to talk about the bearing plate a little bit in a upcoming slide. And there's no tension requirement, it just needs to be taut. And basically you test that by pulling up on the cable. If you can move it more than about an inch, then it needs to be tightened. Otherwise it's good. Okay, this is what I was talking about, the bearing plate. The folks that manufactured this bearing plate did not make a mistake. The hole is not supposed to be in the geometric center of the plate. It's basically 5 inches down from the top, 3 inches up from the bottom. And again, the reason for this is because what happens to the bearing plate when the end post is hit? It's supposed to release immediately. For an end hit, you don't want that in the way. If you put this upside down, if the 5-inch piece is bearing against the base plate, then the post may break away, but this bearing plate may still hang up on the bottom and prevent the cable from releasing. So essentially you need to have the tall end up, the narrow end down. And if it's a wood post, you can toenail it. If it's not a wood post, then you can use a strap. And some of the manufacturers actually have little ears on it, so it's not going to rotate once you put it in place. The rail itself should not be bolted to the first post. The impact head should either be bolted to the post or with lag screws or with metal with bolts if it's metal, but not through the rail. Should be delineated with the stripes facing in the right direction. And I hate to say this in front of some CalTrans people, but they don't always get it right. Okay, we've got some crash-worthy terminal set in concrete. You've got all the posts basically set in concrete, and you've got a bearing plate that not only is upside down, but that's set in concrete too. So if that thing is hit right on the end, it's probably not going to go anywhere. So again, those are some things that one needs to be aware of. Now that bearing plate, I think you would all agree, it's a little bit loose. And here's the reason why it's a little bit loose. Apparently somebody stole the nut off the upper end of the bracket. I don't know why they would do that, but anyway. And again, this is something that if you're just driving by, you're probably not going to notice anything is wrong. You have to be looking for it. And here the obvious concern is, no wonder this cable is sagging. There's no bearing plate at the end with a nut on it. But again, if you're driving by fast, you could easily miss that. Now here's a portion of a dead man anchor. For some reason or other, the cable has disappeared. I'm not sure if that makes the situation better or if it makes it worse. If you hit this on the end, now you've got a bona fide blunt end, and there's a good chance that this rail is going to slice into the passenger compartment. If you had the cable there connected to the back side of the rail and you hit it on the end, once you get to post 2, you're going to stop dead. So basically it's a non-crash worthy terminal with or without the cable. And if it were hit and somebody was able to survive it, when it's replaced, it ought to be replaced with something that's crash worthy. Again, the grading is important. You've got a nice flat approach, but boy, it looks like they dumped a couple of truckloads of dirt here and just let it fall to its natural angle of repose. So, you know, if a vehicle is running off the road and is half over here, it's probably good for maintenance because they're never going to get to the terminal. They're going to roll over and end up in the trees long before they get there. But it's an example of not only poor grading, but probably the wrong choice of terminal. And again, we've said that the flare rates are essential. This is supposed to have a maximum flare rate of 4 feet. Now this is a lot greater than 4 feet. And the end piece for these things basically needs to be straight. If there's almost no way anybody's going to hit this in line with the rest of the rail. So you've got to, again, follow the manufacturer's instructions. Again, like the earlier slide, deflection distance is lacking. The length of need may be inadequate. And by putting it up on a slope, you've increased the chances that somebody's going to run up the slope, go over the rail, and you know they may go as far as the bridge piers if they're terribly unlucky. Okay, one of the things we've seen a lot with wood posts is the lag screws eventually pull out. That makes the head sag, and for an end-on hit, it may or may not work. It may or may not thread the rail through the impact head. Remember, these are called lag bolts, not lag nails. They need to be installed with a pilot hole and a wrench, not with a hammer, if you want them to have any chance of holding. Again, if the rail doesn't fit in the extruder head, then obviously you're going to have some problems. With an end-on hit, this may bypass this entirely. And again, you've got a blunt end that could cause some problems with the motorist. Let's see. Okay, this is an ET head. And it looks okay if you look at it just driving by. The head's sagging a little bit, but it's not the way it should be. Oh, and here again, here's a case where the anchor bracket, the cable bracket did not release. It caused the system to jam. You didn't get hardly much extrusion, and you got a very sudden stop. Here the cable is lying on the ground. So again, for a downstream hit, that's going to pull right off, and you're not going to be redirected. This is a case where they weren't sure which way those shoulder bolts went. So for the top, they put the nuts on the inside. For the bottom, they put them on the outside where they belong. So it's half right. But it's still probably not going to knock off when the extruder head gets to it. Again, when this head hits this, it's supposed to knock it off. But if you've got the bolts here bolted it tight, it's not going to release the way it's supposed to. So again, for the SKT and the fleet, the nuts have to be on the road side of the W beam, not on the back side. We've already talked about this, the 5-inch up, 3-inch down. So I'm not going to dwell on that any longer. This is kind of a comedy of errors. Usually when we have more time, I ask, how many things can you see wrong with this picture? It's pretty close to 6. The first thing I ask is, what's that barrier shielding? If it's supposed to be shielding this post here, it's too short and it's too close to it. It's behind a curb. The stripes are going the wrong way, unless you're trying to direct somebody into this monster. And obviously this thing is a hazard all by itself, so you kind of wonder, what was somebody thinking? And remember, this requires the column strength of the rail. And if this is a very short installation, I've seen one installation actually in my state of Virginia, where this was relatively short, and when the end was hit, it knocked the rail off all of the posts. So again, you have to have enough posts to build up resistance, so the rail is actually forced through the head when it's impacted. Okay, here's a mix and match. You've got an SKT impact head, you've got an ET plus rail and anchor bracket. The anchor bracket doesn't seem to present too much of a problem, but the fact that the standard rail doesn't have slots in it is going to make that initial impact harder than it should be. Again, the SKT and the fleet require a special end piece that has slots cut in it so it can initiate the kinking process. Here's another case where the rail is bolted to the first post, which it's not supposed to be. Only the head is bolted to the post, and you don't have a bearing plate down here. So you'd have a problem with an end-on hit. You'd have a problem with redirection if this cable just pulls through. Okay, here's an energy-absorbing head. Here's a slotted rail, piece of rail. So again, you can't push on a string. That's one of the tenets of engineering. And if you weaken that rail so it doesn't have any column strength, it's not going to feed through the extruder head.
Ground strut.
Ground strut's a little bit high, yes. Good point. I don't think it was specifically brought out, but one of the concerns California had was several of the SKT, the SRT terminals were installed with that second rail element reversed. So when it was all put together, the slot guards were on the upstream side of the slots instead of the downstream side. Now, the reason those slot guards are there is because in the early testing and development of that terminal, without the slot guards, pieces of the vehicle got into the slots and it expanded the rail and caused it to rupture. By putting that slot guard on the downstream side of the slots, it prevents the rail from pulling apart and tearing. So it is important that the slot guards be away from the first post on the downstream side of the slots. And when we were in Los Angeles area recently, we had an opportunity to see several of those that were installed improperly. And the reason we were able to see them so closely is because freeway traffic was stop and go at 10 miles an hour. We got to see it a lot closer than we wanted to. Somebody turn me off? What did I do?
Use that one.
What? One up went out? Okay, I'll use this one. Okay, this is this is an old breakaway cable terminal. There's no ground strut, only 2 posts are weakened. The rail is bolted to each and every post, so for an end-on hit, it becomes very stiff. And of course, the bearing plate is a little bit askew. Okay, to wrap up this this segment, we're going to look at the installation inspection. We're going to look at the connection to essentially a bridge rail if you have one, the transition design, the regular rail, and then the terminal treatment, including the approach to it and the recovery area. Again, when you're looking at a final inspection, these are the kinds of things you need to look at. If you've got a rigid bridge railing, make sure it's connected to the end. If there's no bridge railing, make sure that it adequately shields the downstream end of the hazard, whatever it may be, and is adequately anchored. Again, the downstream end has to be anchored, even if it's not likely to be hit in the opposite direction. We talked about the transition. Again, it has to be firmly connected. You generally use a reduced post spacing, sometimes nested rail, and sometimes a rub rail underneath to prevent wheel contact with the lower part of the concrete bridge rail. Again, follow your standards, and you'll be okay. The run itself, again, the height is important. Make sure you've got the block out set and everything is tightened. That's all pretty straight. The overlapping is important, and then the delineation. Again, California MUTCD requires delineation on its guardrail installations. The terminal, the first thing, make sure you install it according to the manufacturer's instructions. Use the manufacturer's checklist to make sure everything is done right. Make sure the impact head is not bolted to the first post. Make sure the cable is taut and you've got your 4-inch ground clearance maximum. And then again, the approach is again important. It needs to be smooth, traversable, and unobstructed and blend with existing slopes. You don't want to create a slope hazard. No rocks, trees, utility poles, et cetera, that could upset the vehicle prior to impact. Again, you saw that all of these terminals allow some penetration behind it. Well, you didn't see it much for the energy absorbing because we only showed one test. We didn't show the angle test, but even in the angle test, the vehicle gets behind it. So 10 to 1, at least 4 feet behind the terminal, and then ideally blended into a traversable slope beyond that point. Again, unfortunately, it's not terribly unusual to see a lot of guardrail penetrations. What we're trying to do is design something so they're very, very, very rare occurrences. Okay, very quickly, we talked about the basic layout techniques. We looked at common installation errors, and we told you briefly what to look for when you're doing a final inspection. And if you fill out your evaluations for this session, I think we're going to move right into the next session. I think you'd rather get out closer to on time than take a break right now. If you need to take a break, go ahead and do it. But other than that, we're going to move on.